Hi, my name is Na Yun.
Hi, my name is Xiao Cui. Let's introduce our project to you.
First of all, we set the environment by importing necessary packages and setting file direction. The main package that will be used frequently is scatter. Secondly, we import all the data and observe them. Fortunately, there is no long data which need to be cleaned. All the data could be used in this work. In terms of different kinds of variables, some of them are numerical variables while others are categorical variables. We created two lists of them. Uh, the cat list contains hour, minutes, day of week, JPY, AUD, Europe, GBP, US dollar, and the long list contains all other variables.
Since there are more than 200 predictors and many of them are highly correlated, the first idea came out is to use PCA to decrease the number of predictors and reduce the influence of the multicollinearity. Hence, we imported PCA from sklearn decomposition and treated all the predictors from open to lag return 96 into 10 principal components. Then our team splitted the dataset of components and the dataset of results into train sets and test sets, respectively. Then applied a logistic regression on the train sets. After that, we calculated the score of both train sets and the test sets, which is 0.6616 and 0.6668 respectively. We did not satisfy the accuracy, so we plan to find the meaningful features by ourselves. Let's move to the feature analysis part. Uh, in order to do the feature analysis, our team created two functions named stats numerical and stats categorical. The stats numerical function could be used to show the basic statistics of numerical variables such as mean, standard deviation, skewness, kurtosis, quantiles when the final result is up or down. The, uh, the stats categorical function could be used to show the probability of up or down when the categorical variable take different values. From the result of categorical variables, we got some interesting discovery. The probability to get positive return in Monday, is much higher than that in Friday. We have more chance to win from 6 to 7 o'clock than 22 to 23 o'clock. So day of week and hour are potential features that can be used in the models. From the results of numerical variables, we have very valuable finding. When the volume is zero, the corresponding mean of up and down is only 0.001111, which means if the volume is zero, we just predict the up and down is zero, we may get a high score as high as 0.9988. Hence, we predicted all the up and down at zero when the corresponding volume is zero. Then we removed all the data with volume is zero from original dataset and got the new dataset as DF, which is basic dataset we will work on. Let's move to features identifying part. In order to find features for our model, we created plot distribution 1 and plot distribution 2 and the plot category codes function to plot the different distribution shape of variables when the corresponding up and down is 0 and 1. Let's take this plot as an example. The upper plot is under the US market close, the distributions of 8 hours return when the result is up or down, but we cannot find quite big difference from the distributions. Fortunately, we have created these good tools to make the research as followed. So let's begin to find the features. The first feature we want to test is the volume. Volume seems not very significant, but we still want to let it in the model, for we all believe that volume is an important factor that should never be discarded. Then let's move to upper tail. From the upper tail density plot, we can see it's quite different when the result is up or down. Hence, the upper tail can be a feature, so as to the lower tail. Then we want to introduce the SMA compare feature, which means the SMA 20 is bigger than SMA 50. We can see the result that SMA compare is a contrary indicator which can be used. And the ATR plus feature, in technical analysis, ATR is average of true range. We compare the ATR with their mean and get the indicator ATR plus, which can be featured from the result. Then let's move to the CCI flag. CCI strategy seems significant if we split the CCI into CCI bigger than 100 or CCI less than minus 100 and the other situations, which can be a feature in the model as well. And in technical analysis, we often compare SAR with the asset price and then get some clues. We made it as an indicator, and it seems that SAR bigger than price is a good predictor. After work on the numerical variables, we move to consider technical analysis indexes. The first technical analysis index came out in our mind is the 3 white soldiers, or 红三兵 in Chinese, which means when up occurred 3 times periods continuously, the price has an upward trend. So we tried 红三兵 in 5 minutes, 10 minutes, 30 minutes, 1 hour, and 2 hours. The results shows the 30 minutes Hong Sanbing gave significant result. When the 30 minutes Hong Sanbing signal occurred, we have 42% probability to get an up compared with 47% chance to get an up when the signal does not happen. Interestingly, it became a contrary indicator in this liquid market as well. Similar as Hong Sanbing, we also tried several indicators like Yin Bao Yang and 3 crowns. The Yin Bao Yang 12 is another selected indicator. In addition to that, return 2 bigger than 0 and lag return 1 bigger than 0 are also good features that could be used in the model.
In order to try different machine learning algorithms, our team set all the new features we found into the TrainDF dataset. Then we splitted the dataset and put 80% data into data train and the rest 20% data into data test. Since volume equal to 0 is a very important indicator, we got all the volume equal to 0 data from data train and data test into new data sets. After that, we splitted the long zero volume data set train DF without train into X train and Y train, where X train contains all the features and Y train represents the up or down result. Similarly, long zero volume data set taste DF train was splitted into X taste and Y taste. And the most exciting part The most excited part arrived. We are going to try 8 different machine learning algorithms and find the model with the best performance. The algorithms will be tested are logical regression, decision tree, SVM, naive Bayes, KNN, random forest, GBM, and XGBoost. And the result of the logical regression is that the accuracy of the test data is 0.666062, and the result of the decision tree is that the accuracy of the test data is 0.643303, and the result of the SVM is that the accuracy of the test data is 0.650252, and the result of the naive Bayes is that the accuracy of the test data is 0.658912, and the result of the KNN algorithms is that the accuracy of the test data is 0.636657, and the result of the random forest is that the accuracy of the test data is 0.661229, and the result of the GBM is that the accuracy of the test data is 0.633434, and finally the result of the XGBoost is that the accuracy of the test data is 0.639879. In this section, we applied a deep learning algorithms to solve this problem. We use the package Keras, which is written in pure Python and is based on the TensorFlow, which we learned in class. For this problem, we have about 700,000 data about the information of the trend of the price, including open, low, close, volume, return, to train the model, and about 11,000 to test the model. The output of the model is the label of trend of the price. 1 means up and 0 means down. First of all, we should transfer the form of our data because the input for the neural network should be tensor, not list. Therefore, it's going to be 567,000 times 200. Secondly, we need to design network structure for a binary problem whose input is vector. ReLU can be used as an activation function to solve the problem. The output layers use sigmoid to make the network output a probability value between 0 and 1. Binary cross entropy is usually used for the binary classification problems. From the figure of loss and accuracy, we find that validation loss is small and validation accuracy is largest, and apex equal to 31. Therefore, we choose apex 31 to run the model again and get the final results. And the final result is that the loss of this model is 0.4952 and the accuracy of the model is 0.673981. This is all about our project. Thank you.
Thank you for your watching. Thank you.